Welcome back, everyone. Today, we're diving into a topic that's set to revolutionize the maritime world: nuclear-powered cargo ships. That's right, the future of shipping might just be nuclear.
Wait, nuclear cargo ships? You're saying we're putting reactors on vessels that cross the oceans? That's wild.
Exactly. Prachi Patel recently wrote an article titled "The Case for Nuclear Cargo Ships," and it's sparking a lot of interest. The shipping industry is massive, using over 300 million tons of fossil fuels every year and producing about 3% of global greenhouse gas emissions.
I knew shipping was a big polluter, but 3%? That's huge. So nuclear power is the proposed solution?
Yes. With the International Maritime Organization setting ambitious net zero emissions goals for 2050, the industry is under pressure to find viable alternatives. While options like ammonia, batteries and hydrogen are being explored, they come with significant drawbacks.
Right, like batteries aren't feasible for long voyages, and producing green ammonia requires a ton of energy. But nuclear power, how practical is that for commercial ships?
Very practical, actually. Nuclear-powered ships can operate for years without refueling, thanks to the high energy density of nuclear fuel. This means smaller fuel tanks and more space for cargo or passengers.
Okay, that sounds efficient, but what about safety? Aren't nuclear reactors risky?
Great question. Modern reactor designs, especially Generation 4 small modular reactors, or SMRs, have advanced safety features. They operate at low pressures, which makes explosions extremely unlikely. For example, molten salt reactors use liquid fuel and coolant, which can solidify in case of an emergency, preventing the spread of radioactive material.
So the risk of a meltdown is minimized, but how does that work exactly?
Take triso fuel, used in some gas-cooled reactors. It consists of uranium particles encapsulated in layers that can withstand extremely high temperatures. This means even if things get hot, the fuel doesn't melt down. It's like having a chocolate chip that won't melt in a cookie, no matter how long you bake it.
Wow, that's a neat analogy. But what about the crew? Do they need to be nuclear scientists to operate these ships?
Not necessarily. While specialized training is required, the reactor's control systems are designed to be user-friendly. Automation handles much of the complexity, so the crew doesn't need to be nuclear engineers.
All right, but I'm thinking about pirates now. Wouldn't a nuclear-powered ship be a target?
Interesting tangent. In reality, nuclear-powered ships would be less attractive targets. The reactors are built with security in mind, and accessing nuclear material isn't straightforward. Plus, the value for pirates lies more in the cargo than the ship's propulsion system.
Okay, that makes sense, but what about nuclear waste? How do we deal with that on a ship?
Some advanced reactor designs can actually use nuclear waste as fuel. For instance, lead-cooled fast reactors can recycle byproducts from conventional reactors. This not only reduces waste but also provides a sustainable fuel source.
So we're turning yesterday's waste into today's fuel? That's fascinating.
Exactly. It's a circular solution that benefits both energy production and waste management.
But let's talk about ports. Will they allow nuclear ships to dock? I imagine there might be some resistance.
You're right. Regulatory hurdles and public perception are significant challenges. However, efforts are underway to harmonize regulations internationally. Organizations are recognizing the need for unified guidelines to safely integrate nuclear-powered vessels into global shipping.
Maybe with time and proven safety records, acceptance will grow. Are there any real-world examples of nuclear-powered commercial ships?
Yes, though they're rare. The Russian cargo ship Sevmorput, commissioned in 1988, is one example that's still in operation today. It demonstrates that nuclear propulsion in commercial vessels is feasible.
Interesting. So if it's been done before, why hasn't it caught on?
Historically, the high costs and complexity of earlier reactor designs made them less economically viable. But with modern SMRs being more efficient and cost-effective, the landscape is changing.
Got it. What about environmental benefits beyond emissions reduction?
Nuclear-powered ships eliminate the risk of oil spills, which are devastating to marine ecosystems. Plus, without the need to bunker fuel, there's less disruption to port operations.
That's a good point. Fewer fuel stops mean faster shipping times too, right?
Exactly. It's like driving a car that doesn't need to refuel for years. You save time and increase operational efficiency.
But producing these reactors must be energy intensive. Does that offset the environmental benefits?
While reactor construction requires energy, the long-term emission savings far outweigh the initial inputs. Over a ship's lifespan, the reduction in greenhouse gases is substantial.
Makes sense. Are there any companies leading the charge in developing these nuclear ships?
Several. For instance, Nucleo and Fincantieri are conducting feasibility studies for marine reactors. Core Power is working on molten salt reactors for maritime use, and there's significant interest in South Korea as well.
It's exciting to see this momentum. Do you think we'll see nuclear-powered cargo ships in the next decade?
It's possible. With ongoing research and increasing regulatory support, we might witness the first commercial nuclear-powered vessels setting sail within 10 years.
That would be a game-changer. But shifting gears, could these reactors be used for other purposes on the ship?
Absolutely. The high energy output could support onboard systems like desalination plants, electric systems, and even act as mobile power stations in emergencies.
Imagine a fleet of ships that can not only transport goods but also provide power where it's needed. That's revolutionary.
Indeed. The potential applications extend beyond shipping and could impact global energy distribution.
This has been an eye-opening discussion. I'm excited to see how this develops.
Me too. The case for nuclear cargo ships is strong, and as technology advances, we may well see the dawn of a new era in maritime shipping.
Thanks for breaking this down. I feel like I've just had a masterclass in future shipping technology.
Glad to hear it, and thank you to our listeners for joining us on this fascinating journey. Until next time, see you in the next one.